Hello guys, this is Dhanvantesh. Today I'm going to discuss about the quick selection sort with its time complexity. In this video, you will get to know that what is a selection sort and what are its application in real life, and also what its time complexity and its space complexity. And you will get to know what you mean by time complexity and space complexity and the difference between it at the end of this PPT. Let me present introduction to selection sort. Selection sort is a simple sorting algorithm. Well, we use right. If we give in a mixed wrap of a numbers, we need to convert into ascending number. Then we use a sorting techniques. It is one of the type of sorting, but we use mostly quick sort because it levels because the time complexity is efficient, works fine, but yeah, it's good, but it uses two loops. Wherever quicksort uses one loop, yeah. You mean the difference? I'm not discussing this difference in this session, but in later upcoming videos, I'm going to discuss it later. But today, I'm going to teach you about these topics: what is quick selection sort and its applications, and its time complexity and space complexity as well. Yeah. Finding the minimum element from the unsorted part of the array and swapping it first element of the unsorted part. This is this is my name, Dhanvanteshis, and the time complexity of selection sort. Yeah, this part I'm going to discuss at last because you need to know about the algorithm and its program, right? So I'm going to discuss this later. Let's move on. Pseudocode. Yeah, let's come here. Pseudocode for selection sort. The pseudocode for the selection sort algorithm is as follows: procedure selection sort A, repeat n minus 1 times. Why we need to repeat n minus 1? I will say, look at the 20, 12, 10, 15, 2. Then the first goes to 22 n minus 1. N is 2 means n minus 1 is 15. So from 20 to 15, it will move. Then find the minimum element in the unsorted part of E. Yeah, it will. It is whether 20 is less than 12. No, right? Whether 12 is less than 10. No. Whether 10 is less than 15. Yes, right? Then it will swap, right? Then 15. Then 10. Check with the 2. Yes, it swap. The swap done there. Likewise, it will swap. And let's come across the Yeah, how selection sort of works. Find minimum. First, we need to find minimum, right? In this array, we need to find the minimum. Then we need to swap and then repeat again. Identify the smallest element in this unsorted portion of the array and swap. Move the minimum element to the beginning of the unsorted position. Repeat it. Repeat the process for the remaining unsorted elements. Selection sort works by iterative finding the minimum element from the unsorted part of the array and swapping it with the first element of the unsorted portion. And this process is repeated until the entire array is sorted in ascending order. Yeah, let's find advantages and disadvantages of selection sort. Advantages of selection sort. Simplicity. Selection sort is a simple and straightforward algorithm, making it easy to understand and implement, especially for beginners learning about sorting algorithms. Sorting algorithms like BDAC. It is not in the same way, right? Alphabets will start from A, B, C, D. Likewise, it will sort A, B, C, D. In place operations. Selection sort is an in place sorting algorithm, meaning it only requires a constant amount of extra space, making it memory efficient for large data sets. Then let us come across the minimal comparison. Yeah. The selection sort only needs to make what do you mean by needs to make comparisons which is fewer than other sorting algorithms like bubble sort, making it efficient for certain users. Yeah. Comparison to other sorting algorithms, time complexity, memory usage, and stability. Selection sort has a time complexity of 0 n square. I mean, the two loops are repeated. That's why n square has been given, making it less efficient than algorithms like quicksort and merge sort, which have average case time complexity of n log n memory usage. Selection sort is considered an in-place sorting algorithm, meaning in it uses a constant amount of extra space, making it memory efficient compared to algorithms that require additional data structures. Stability. Unlike some other sorting algorithms, selection sort is a stable sort preserving the relative order of equal elements in the input array. Real world application of selection sort, color, shape, size, it can be used anywhere. That despite its simplicity, selection sort has a practical application in real world. It is commonly used for sorting small data sets or when memory usage is a concern. Selection sort is often employed in embedded systems where processing power and memory are limited. Additionally, selection sort can be useful in situations where the input data is mostly sorted or where the cost of swapping elements is high, such as in sorting physical objects. Conclusion and key takeaways. In conclusions, selection sort is a simple and in what when I say that the algorithm, right? The selection sort algorithm is very intuitive. I can say that it is a very simple and intuitive sorting algorithm that has a time complexity of 0 and square. Sorry, it's a O n square, making it suitable for small to medium sized data sets, while it may not be used for most sufficient algorithm for large scale applications. For large scale applications, we use quicksort. Let's come across time complexity of selection sort. Selection sort has a time complexity of O n square, which means the algorithms running the grows quadratically with the size of the input. This makes it less efficient for large data sets compared to the algorithms with better time complexity, such as O n log n. Algorithms like quicksort or merge sort. Best case is 0 n square, worst case is 0 n square, average case is 0 n square. The time complexity is the same across best, worst, and average cases because the algorithm performs the same number of comparisons and swappers regardless of the initial order of the input data. Yeah, look at here. Yeah, I said I have written here the same thing has been like yeah. If you given the best case, worst case, and reduction is the same, right? Yeah. Whether you given ascending order, whatever the is sorted array, it will sort again. It will check, right? That's why it's a worst case, right? Average case is what if you give unsorted or sorted, it will sort. If you give an sorted array, it will sort. That's the worst case. If you give for average case is like if you give sorted or unsorted, it will sort. That's average case. Average case. So I mean by best case is nothing but if you give a sorted unsorted array, it will sort, right? That's the best case. Yeah. Real world applications of selection sort. Selection sort is a simple, intuitive. I have discussed it here, right? Simple, yeah, that has practical uses in various real-world scenarios. Its straightforward implementations of stability make it suitable for by sorting small to medium-sized data sets, especially when memory usage is a concern. One common application is sorting databases and spreadsheets where the data size is manageable and the algorithm efficiency is sufficient. Selection sort is also used in embedded systems and resource-constrained environments, where the simplicity of the algorithm is more important than asymptotic performance. Thank you, guys. Sorry, have the next page is conclusion and key takeaways. In the conclusion, selection sort is a simple and intuitive. What I am being by this, I have repeated here also. Come on, let's do again. Sorting algorithm with a time complexity of O n square and making it suitable for small data sets while it is not efficient as algorithm like quicksort, merge sort, selection sort has advantages in certain scenarios and is easy to understand and implement. The key takeaways from this presentation. So selection sort as a time complexity of 0 n square, making it less efficient for large data sets. It is easy to implement and understand, making it a good choice for educational purpose. Selection sort can be useful in situations where the input is small or partially sorted, while not the most efficient sorting algorithm. Selection sort has its place in the algorithm toolbox. Thank you, dear my friends, for watching this video. Hope you got the well informations from me. I will meet you in next video. Tag.